Welcome to Beyond the Brackets. Today we'll look into functions of a complex variable, which is a fundamental concept in complex analysis. Let z is equal to x plus iy be a complex variable where x is the real part of z and y is the imaginary part of z, where I is given as root of -1. Suppose d is a set of complex numbers. A function f defined on d is a rule that assigns to each complex number in D another complex number w. We write w is equal to f of z. In general, the function can be written as w is equal to f of z is equal to u plus iv, where u is the real part of w and v is the imaginary part of w. Let's look at an example to understand this concept. Here f of z is given as z square. So in the first case, when z is equal to 2 plus I, f of z will be equal to 2 plus I whole square. Expanding this using the formula a plus b whole square, we get 4 plus I square plus 4I, which will be equal to 3 plus 4I. Compare this with the standard form w is equal to u plus iv. We get u, which is the real part, as 3 and v, which is the imaginary part, as 4. When z is equal to 1 plus 3i, we get f of z as 1 plus 3i whole square. Again, expanding using the formula a plus b whole square, we get 1 plus 9i square plus 6i, which will be equal to minus 8 plus 6i. Comparing this with the standard form w is equal to u plus iv, we get real part u as minus 8 and imaginary part v as 6. In the next question, f of z is given as z square plus z. To find its real and imaginary parts, consider z is equal to x plus iy. So f of z will be equal to x plus iy whole square plus x plus iy. Expanding this using the formula a plus b whole square, we get x square plus I square y square plus 2ixy plus x plus iy. Separating the real and imaginary terms, we get x square. Since I square can be written as -1, so it becomes minus y square plus x plus I into 2xy plus y. Comparing this with the standard form w is equal to u plus iv, we get real part u is equal to x square minus y square plus x and the imaginary part v is equal to 2xy plus y. In the next part, we are supposed to find f of z at 1 plus I. Given f of z is z square plus z, substituting z is equal to 1 plus I, we get 1 plus I whole square plus 1 plus I. Expanding this using the formula a plus b whole square, we get 1 plus I square plus 2I plus 1 plus I. Here I square will be equal to -1 and this term further simplifies to 1 plus 3I. Moving on to the next question, f of z is given as iz plus 3z bar and we are supposed to find the value of u and v, that is real imaginary part of f of z. Since f of z is iz plus 3z bar, substitute z is equal to x plus iy, we get I into x plus iy plus 3 into z bar will be equal to x minus iy. Again, I square will be -1. Comparing this with the standard form u plus iv, we get a real part u is equal to 3x minus y and imaginary part v is equal to x minus 3y. In the second part of the question, we are asked to find the value of f of z at 1 plus 4i. Since f of z is iz plus 3z bar, so substituting z is equal to 1 plus 4i, we get I into 1 plus 4i plus 3 into 1 minus 4i. Again, I square will be equal to -1, so this will be simplified to -1 minus 11i.